Hello and good day. My name is Shahid Khan and I am a chemical engineer. I have prepared a training course on steam boilers. This course will refresh your knowledge on boilers. This course is beneficial for all personnel from operators to engineers who are working with boilers. After completing this course, you will be able to describe the basics of boiler operation, describe a fire tube boiler, describe the main components of a water tube boiler and explain how it operates. List some boiler operating problems. Distinguish between superheated and desuperheated steam. Describe the primary responsibilities of a boiler technician. Describe an inverted bucket steam trap. Describe a float steam trap. Describe the bellows thermostatic steam trap. Before starting the course, let's have a look on key terms of steam boilers and condensate system. Bellows trap is a thermostatic steam trap that operates by opening or closing a bellows as the temperature changes. This movement opens and closes a valve. Boiler load is the plant demand for steam. Burner is used to evenly distribute air and fuel vapors over an ignition source and into a boiler firebox. Damper is a device used to regulate airflow. Desuperheating is a process applied to remove heat from superheated steam. Downcomers are the inlet tubes from the upper to lower drum of a water tube boiler. These tubes contain hot water. Economizer is a section of a fired boiler used to heat feed water before it enters the steam drums. Fire tube boiler is a type of boiler that passes hot gases through tubes to heat and vaporize water. Flame impingement is frequent or sustained contact between flames and tubes in fire tube boilers and furnaces. Float steam trap is a steam trap that operates with a float that opens a valve as the condensate level rises. Inverted bucket steam trap is a mechanical steam trap that operates with an inverted bucket inside a casing, effective on condensate and non-condensing vapors. Mud drum is the lower drum of a water tube boiler. Risers are the tubes from the lower drum to the upper drum of a water tube boiler. These tubes contain steam and water. Spuds are gas-filled sections in a boiler fuel gas burner. Steam generating drum is a large upper drum partially filled with feed water. This drum is the central component of a boiler. It is connected to the lower mud drum by the downcomer and riser tubes and receives steam from the steam generating tubes. Steam trap is a device used to separate condensate from steam and return it to the boiler to be converted to steam. Superheated steam is steam that is heated to a higher temperature. Thermostatic steam trap is a type of steam trap that is controlled by temperature changes. Water hammer is a condition in a boiler in which slugs of condensate, water, flowing with steam damage equipment. Water tube boiler is a type of boiler that passes water-filled tubes through a heated firebox. Boiler applications and basic operation. Steam generators, or, as they are commonly called, boilers, are used by industrial manufacturers to produce steam. Steam is used to operate steam turbines, distillation systems, and reaction systems. They can be used for such processes as laminating, vulcanizing, extrusion, firefighting, and flare systems, and to provide cooling or heating to process equipment. Boilers use a combination of radiant, conductive, and convective heat transfer methods to change water to steam. A simple boiler consists of a heat source, water-containing drum, water inlet, and steam outlet is shown in picture. As heat is added to the drum, the temperature increases until the water boils. As the steam rises, it is captured in a line and sent on for further processing. Factors that affect boiler operation are density differences for internal circulation, pressure, temperature, and water level. Fire tube boilers. A more complicated boiler is the fire tube boiler, which resembles a modified shell end tube heat exchanger. This type of boiler is composed of a shell and a series of tubes designed to transfer heat from the fire tubes and into boiler feed water. Combustion gases exit through a chamber similar to an exchanger head and pass safely out of the boiler. The water level in the boiler shell is maintained above the tubes to protect them from overheating. The term fire tube denotes that the heat source is from within the tubes. A fire tube boiler shown in these pictures consists of a boiler shell with feed inlet and outlet connections, fire tubes, a combustion tube, burner, feed water inlet, steam outlet, combustion gas exhaust port, and tube sheets. Water tube boilers. The most common type of large commercial boiler is a water tube boiler as shown in picture. A water tube boiler consists of an upper and lower drum connected by tubes. The lower drum and water tubes are filled completely with water, whereas the upper drum is only partially full. This arrangement allows steam to pass through mechanical separators in the upper drum, flow to a superheater section, and then exit the boiler. As heat is applied to the boiler firebox, water flows from the upper drum through downcomers into the lower drum. Tubes, called risers, cause water and steam to flow into the upper drum because of density differences. Boiler water circulation operates under the principle of differential density. When a fluid is heated, it expands and becomes less dense. Cooler water flows from the upper or steam drum through the downcomers to mud drum, the lower drum, and then rises as some steam is generated. Circulation continues, and makeup water is added to the upper drum to replace the steam that is generated. Water circulation continues in a water tube boiler because steam bubbles in the lower drum move up the riser tubes and cause water density to decrease. The cooler water in the downcomer flows into the mud drum. The riser and steam generating tubes are physically located near the burners. Steam moves up the riser and steam generating tubes and into the upper steam generating drum. Steam generation causes pressure to rise. When the target pressure is achieved, the boiler is placed on the line. Pressure is maintained by adding makeup water and continuously applying heat. Main components. Furnace. The water tube boiler firebox, that is, the furnace, is designed to reduce the loss of heat and enhance the heat energy being applied to the boiler's internal components. Boiler furnaces have a refractory lining, burners, convection type section, radiant section, fans, oxygen control, stack, damper, and many other components associated with fired heaters. Tubes. Boilers contain several types of tubes. Steam generating tubes are attached to the upper and lower drums. Flow goes through the firebox and back up to the upper steam drum. Downcomer tubes are warm water tubes connecting the upper and lower drums. Risers are hot water tubes between the upper and lower drums. A water makeup line flows into the upper drum. Steam is removed from the upper steam generating drum and heated to the desired temperature in superheater tubes. Superheated steam temperature can be increased as it re-enters the furnace. Some processes cannot handle high temperatures, so the superheated steam is cooled off. This process is called desuperheating. Drums. The drums inside a boiler furnace are pressure cylinders connected by a complex network of tubes. The drums are classified as the upper, steam, drum and the lower, mud, drum. The steam drum contains a water-steam interface. The upper drum contains the feed water inlet distributor, a blowdown header, and water separation equipment. The lower mud drum is always full of liquid. Gas and oil burners. Most boilers use natural gas or atomized fuel oil burners to provide heat to the furnace. Burners inject air and fuel through a distribution system that mixes them into the correct concentrations so combustion can occur easily. Some large boilers, primarily in electrical generating plants, burn coal. The key components of the combustion apparatus shown in picture include the following. Dampers that regulate air into the burner. Air ducts with fixed blades that create a swirling effect as air enters the furnace. Components called spuds that distribute fuel gas. An igniter that works like a spark plug to ignite the flammable mixture. Flame detection instruments shut off fuel gas if the flame goes out, and factory mutual valves, FM valves, shut off fuel gas when potentially dangerous situations arise, such as low drum level and flame failure. Most plant boilers use forced draft fans to supply combustion air. Economizer section. The economizer section shown in picture is used to increase boiler efficiency by preheating the water as it enters the system. This section is a series of headers and tubes located between the firebox and the stack. Temperatures are typically lower in the economizer section than in the rest of the system, but the hot flue gases moving out of the firebox and into the stack still have enough heat to offset energy costs. The economizer section in a boiler is very similar to the convection section in a fired heater system. Both operate under the energy-saving concept of using the hot flue gases before they are lost out the stack. We will now discuss boiler functions. When a boiler is being started up, the following process occurs. The furnace, which contains cool water in drums and tubes, starts to heat up. When the burners are lit, hot combustion gases begin to flow over the generating tubes, riser tubes, downcomer tubes, and drums. Radiant, convective, and conductive heat transfer begin to take place. Hot gases flow out of the firebox into the economizer section and out the stack. Water temperature increases at programmed rates. Pressure begins to increase. Steam may initially be vented to the atmosphere. As the temperature of the water inside the generating and riser tubes increases, the density of the water decreases and initial circulation is established. Bubbles begin to form and rise in the water, increasing circulation and pressure as shown in picture. This circulation rate can easily reach 2 million pounds per hour. At this point, approximately 65,000 pounds per hour of steam is being produced. Each time the water passes through the tubes, it picks up more heat energy. When the pressure increases to slightly above the system pressure, steam will flow through the non-return valve into the system. Boiler load is a term used to describe the plant's demand for steam. Let us discuss now steam. As long as steam and water are in contact with each other, the steam is saturated. This saturated condition means that for every temperature of water, a corresponding pressure of steam exists. The pressure on the water sets the temperature as long as the steam and water are in contact. Basic boiler design removes the steam from the upper steam water drum and heats it up at essentially the same pressure. This process is referred to as superheating. Some plant processes cannot tolerate high temperatures. The process of cooling the superheated steam is referred to as desuperheating. During the desuperheating process, part of the superheated steam is returned to the steam drum. The cooler liquid in the steam drum removes heat from the superheated stream and allows it to be used in specific plant processes. Boiler operation. Starting up a boiler requires the following steps. 1. Fill the steam drum with water to the normal level. 2. Start the fan. 3. Purge the furnace. 4. Check furnace for percentage of flammables. 5. Light the burners. 6. Bring the boiler up to pressure. 7. Place the boiler online. Each of these steps requires the operator to perform a number of tasks. These tasks vary from site to site, and you will spend many hours training for your specific procedure before being allowed to operate the boiler. Because each site is different, it is difficult to identify every task a boiler operator has. The most common operator responsibilities are related to the prevention of typical boiler problems. Typical boiler problems include tube rupture, soot buildup in superheater and economizer tubes, loss of water flow, flame impingement, frequent or sustained contact between flame and tubes, scale, impurities in steam or water, flame failure, and improper water level. It is usually the operator's responsibility to control water and steam flow rates and temperatures and water level in the boiler. The operator also checks for smoke and checks burner and flame pattern. The operator maintains good housekeeping and unit logs and checks fuel pressure and temperature and oxygen level. Finally, the operator monitors the pressure of the firebox and drum, the temperatures in the firebox, stack, superheater, and superheater temperatures, and ensures fan operation. Let's now discuss steam systems. Steam is used in a variety of applications in industrial manufacturing environments. There is a considerable cost incurred in the treatment and production of steam, so steam reclamation is an important and common feature at most companies that use steam in their processes. As steam flows from the boiler to the plant, it begins to cool. As it cools, condensate is formed. Condensate can cause many of serious problems as it flows with the steam. Slugs of water can damage equipment and lead to a condition known as water hammer. Devices known as steam traps are used to remove condensate. Steam traps are grouped into two categories, mechanical and thermostatic. Mechanical steam traps include inverted buckets and floats. Thermostatic traps include bellows-type traps. A steam system that includes a steam trap is shown in picture. Inverted bucket steam trap. The inverted bucket steam trap shown in picture is a simple mechanical device used to remove condensate from steam and return it to a condensate header. The condensate header runs back to the boiler, where clean condensate is converted to steam. Inverted bucket traps can handle condensate, air, and other non-condensable gases such as nitrogen and oxygen. During operation, the steam enters the bottom of the trap via the inlet and fills the inverted bucket. An air vent is located on the top of the bucket. Gases escape through this hole and into the outlet line. The outlet valve is also located on the top of the inverted bucket. The position of the bucket determines whether the valve is open or shut. When the bucket is in the lower position, the valve is open. When the bucket is in the upper position, the valve is closed. Condensate in the steam drops to the bottom of the inverted bucket and gases escape out the air vent. When the body of the bucket trap is full of condensate, the inverted bucket rests on the bottom. The outlet valve on the top of the inverted bucket is in the open position. As steam fills the inverted bucket, the bucket rises and the valve closes. Float steam trap. Another type of mechanical steam trap is a float. Float-type traps have a float that rests on the top of the condensate shown in picture. A rod to the outlet valve attaches the float. The position of the float determines the position of the valve. As the level in the trap increases, the float lifts, allowing condensate to flow. Float steam traps feature the following components: body, inlet and outlet, bonnet, float, rod, valve. Float traps are not designed to handle non-condensable gases. Non-condensable gases can keep the float trap from operating properly. This condition is referred to as being airbound. Bellows thermostatic steam trap. One of the most popular steam traps is the thermostatic steam trap. Thermostatic steam traps are cheaper and selected more frequently than any other. This type of trap responds to the temperature differences between condensate and steam. A common thermostatic trap design is the bellows trap shown in picture. During operation, steam enters the bottom of the trap and comes into contact with the bellows. Condensate causes the bellows to contract and open. Steam causes the bellows to expand and close. Bellows traps can handle condensate and non-condensable gases. Steam generation system. Steam generating systems are very large and very complex. Modern control instrumentation makes the operation and control of this type of system much easier. There are a number of hazards associated with the boiling water and the steam produced. High-pressure steam directed in a narrow beam can cut a broomstick in half. High-pressure steam can also provide rotational energy to a steam turbine. Instrument systems are only as useful as the technicians are that work with them. Alarms that are ignored or bypassed, control loops that are left in manual or process problems that are ignored can lead to serious consequences. The primary purpose of B402 steam generation system is to provide 120 psig of steam to X205 kettle reboiler. The X205 is used to maintain energy balance on the debutanizer column. This medium pressure steam is also used in a variety of other applications. When B402 is initially started up, a series of steps are followed. One of the most important safety concerns is to establish water flow and drum levels prior to lighting off the burner. When the burners are lit, hot combustion gases begin to flow over the generating tubes, riser tubes, downcomer tubes, and drums. Radiant, conductive, and convective heat transfer begin to take place. Hot combustion gases flow out of the firebox into the economizer section and out the stack. Fans provide airflow through the furnace, creating a slight draft or negative pressure. Since the furnace is hotter than the outside air, significant density differences exist. Water temperature increases at programmed rates. Pressure begins to increase inside the large vapor disengaging cavity in the upper drum. As the temperature of the water inside the generating and riser tubes increases, the density of the water decreases and initial circulation is established. Bubbles begin to form and rise in the water, increasing circulation and pressure. Each time the water passes through the tubes, it picks up more heat energy. When the pressure increases to slightly above the system pressure set point, steam will flow to the header. Inside the upper steam generating drum of B402, steam and water come into physical contact, saturating the steam. This saturated condition means that for every temperature of water, a corresponding pressure of steam exists. The pressure on the water sets the temperature as long as the steam and water are in contact. Basic boiler design removes the steam from the upper steam water drum and superheats it at essentially the same pressure. B402 is designed to operate at 120 psig. However, some operating facilities require low-pressure steam. This is when desuperheating is used. During the desuperheating process, part of the superheated steam is routed through the boiling liquid in the steam drum, cooling it down to a lower pressure. The boiling water is cooler than the 120 psig steam and reduces the pressure to around 60 psig. A number of hazards are associated with the operation of a boiler system. Some of these hazards include hazards associated with high-temperature steam, burns, hazards associated with using natural gas, hazards associated with leaks, instrument failures, hazards associated with confined space entry, opening and blinding, isolation of hazardous energy permit labeled lockout, tagout, routine work on equipment and facilities, hazards associated with lighting burners, exceeding boiler temperatures or pressures, hazards associated with using water treatment chemicals, error with valve lineup resulting in explosion or fire. While a large list of potential hazards exists beyond the above list, it indicates that careful training is required for all new technicians assigned to utilities. This picture illustrates a steam generation system. Steam system symbols. Steam system devices can be represented as symbols. This picture shows steam system symbols. Now I will discuss the simple startup procedure for steam generation system. Consider this picture of our steam system. We want to start up this system. To start the system, follow these steps. 1. Notify your supervisor and all concerned about startup. Downstream process technicians, instruments and electrical, engineering, maintenance, etc. 2. Ensure all safety hazards are secured. Trash, locks, old permits, etc. 3. Check equipment and instrumentation. Stroke control valves 0 to 100%, check lineups, etc. 4. Line up P4025. Set FIC 402C to 150 GPM and place controller in cascade. 6. Set LIC 402 to 50% and place controller in auto. 7. Set PIC 402A to 120 sig and place in auto. 8. Ensure level in durator is at 50% and water makeup is lined up. 9. Start pump 402 and monitor system pressures. Establish proper level in upper and lower drum. 10. Open PCV 402B to 100% and leave in manual. 11. Open FCV 402A to 100% and leave in manual. 12. Ensure boiler has been purged with steam for 10 minutes. 13. Monitor process pressures and level in TK 402. 14. Ensure pilot light on burner 1 is active. 15. Set FIC 402A to 50% and place controller in auto. 16. Set PIC 402B to -0.05 and place controller in auto. 17. Set FIC 402B to 50% and place in auto. 18. Start fans 402A and 402B. 19. Light burner and allow boiler to come up to pressure and temperature. 20. Monitor oxygen level and ensure it stays between 0 and 10%. 21. Monitor TR402 video trends. 22. Monitor all process variables on the stack. 23. Cross-check process variables with spec sheet. These are specification sheets and checklists for level, flow, analytical, pressure, and temperature. To summarize this course, I would say boilers, steam generators, are devices that produce steam. They use a combination of radiant, conductive, and convective heat transfer methods to change water to steam. Factors that affect boiler operation are density differences for internal circulation, pressure, temperature, and water level. A fire tube boiler resembles a shell end tube heat exchanger in that it has a series of tubes enclosed in a shell. The tubes are heated by hot combustion gases and are submerged in water. Heat is transferred from the hot tubes to the liquid through conduction and convection. The most common type of large commercial boiler is the water tube boiler, which consists of a furnace that contains an upper and lower drum connected by tubes. Circulation through the system depends on density differences in the water in the various tubes. This type of boiler produces superheated and desuperheated steam. Steam systems designed to reclaim steam use steam traps to remove condensate. Steam traps are grouped into two categories: mechanical, inverted bucket steam trap, and float steam trap, and thermostatic. Thermostatic steam traps are cheaper and selected more frequently than any other. They respond to the temperature differences between condensate and steam. A common thermostatic trap design is the bellows trap. That's all, gentlemen. I hope this training course have refreshed your knowledge regarding to boilers and steam system. Good day and good luck.